Good morning, students. In the previous period, we have calculated the equation for time period of the lattice pendulum, and we have got this type of equation in that period. Now, we'll solve this equation. For solving this equation, we have assumed something. The time period t1 square equals to t square plus alpha, and time period t2 square equals to t square minus alpha. Here I write, but we assume that we assume that the time period assume that but we assume that t1 square equals to t1 square equals to t square plus alpha, t square plus alpha square, and t2 square equals to t square minus alpha square. Okay, then we can calculate the values of t square and alpha square from these equations. Now I can write from this equation that alpha square equals to, from the left hand side, I can write here alpha square equals to t1 square minus t square. Alpha square equals to t1 square minus alpha square. Similarly, from this equation, I can write the value for alpha square equals to t square minus t2 square. Okay, from here I got this value of alpha square equals to, this alpha is shifted to the left hand side and this t2 square shifted to the right hand side. As if we see these two equations, from these two equations we see that the left hand side of these two equations is same. Therefore, we can compare the right hand side, and that right hand side is t2 square, t1 square minus t square equals to t square minus t2 square. Here I can calculate the value of t square. Here I can calculate the value of t square. Now here in this equation, what I do, this t2 square I will take it to the left hand side, that is t2 square, and this t I will shift to the right hand side, that is t plus t square, and this can be written as 2t square equals to t1 square plus t2 square, and hence we write t square equals to t1 square plus t2 square upon 2. This is the value of t square we have calculated from these two equations. Now similarly, we can calculate the value of t square also, and right here, and I can write the t1 square equals to t square minus alpha. I can write here t square minus alpha square. t1 square equals to t square minus alpha square, and t2 square equals to, and t2 square equals to t square plus alpha square. T square, here it is t square plus alpha square, and it is t square minus alpha square. Now we have calculated the value for t square. Now here we want to calculate the value of alpha square. Therefore, for calculating alpha square equals to, what we will do, we write this equation as t square equals to, what is it? I will write that from this here simply t square equals to t1 square alpha, t1 square minus alpha square, and t square equals to t2 square plus alpha square, t2 square plus alpha square. Now similarly here the left hand side is same, therefore right hand side is also same, therefore t1 square minus alpha equal to, this equation is like this, t1 square minus alpha and t2 square plus alpha square. Now we want the value of alpha square, therefore I write here t1 square minus t2 square equals to 2 alpha square, and therefore alpha square equals to t1 square minus t2 square upon 2. This is the value of alpha square. Now putting this value of alpha square and t square into the previous equation, that equation is like this, here I write that. Now we get, therefore putting the values of t square and alpha square in equation 6, we have 4 pi square upon z equal to t square, t1 t2 square, t1 square plus t2 square, t1 square plus t2 square, t1 square plus t2 square upon 2 into L1 plus L2 plus t1 minus t2 square, t1 square minus t2 square upon 2 into L1 minus L2. Simply just making the adjustment or multiplying by 2 to the equation, then we get 8 pi square upon z equals to t1 square plus t2 square upon L1 plus L2 plus here t1 square minus t2 square upon L1 minus L2. As we have multiplied this equation by 2, therefore we get this type of equation. This equation can be written for z, therefore z equals to 8 pi square upon t1 square plus t2 square upon L1 plus L2 plus t1 square minus t2 square upon L1 minus L2. In this way, we can calculate the value of acceleration due to gravity by the Getter's pendulum, and this is the equation for acceleration due to gravity. In this way, we have completed this point here, that is the Getter's pendulum. Today we'll stop here.